Hi, I am Mithilesh. In this lecture, we're going to see constructions. Construction of a line segment, construction of a triangle, and construction of a tangent to a circle from an external point. We are familiar with the construction of perpendicular bisector of line segments, bisecting angles, and construction of triangles before. In this lecture, we will see guidelines of more constructions based on the previous ones. Well, how do we divide a line segment in the given ratio m:n? We'll always follow steps of construction and you have to write them in your examination. Draw a ray at an acute angle to the given side AB. AB is here given to us and we have to draw a ray which is extending in this direction at an acute angle theta. Make m plus n parts of the ray of equal lengths. M:n is the ratio which is given to us. So we have to add m plus n and make those many number of equal parts on the ray. Suppose my m:n is 2:2. I have 2 plus 2 is equal to 4 and I have to make 4 parts like this. Join the last point to B. If I have this as my last point, then I have to join B like this. Then catch hold of the point corresponding to M and extend it parallel to BA. Now, if he asked us to calculate 2:2, then we take or consider M over here as 2. So we catch hold of the second point from here and extend it parallel to this point or this line. And if I mark a point here, it should be approximately the half, as 2:2 is also 1:1. Since I don't have a ruler here, just approximate the value which I'm getting over here. Let's see how we construct a triangle with 3/4 size of the original one. The steps of construction are: draw any ray BX making an acute angle with BC. BC is the base which is given to us. On the side opposite to the vertex of A. If I am expecting my vertex here in this point, then I have to draw it opposite over here. Locate 4 greater of 3 and 4 in 3/4. I have my size to be reduced as 3/4 of the original one. And I have to take greater of 3 and 4 in the ratio and mark 4 points equidistant from B on the ray similar to the line segments 1. So I have drawn a ray from here, B. This is my ray here. And I have divided it into 4 equal parts, 1, 2, 3, 4, and I have joined the last part to my C over here. Now I want 3/4 size of the original one, so I pointed my 3 over here and extended it parallel to this point up to BC and named this point as C dash. Join B4 to the point C and extend 3 also in a similar way. Now from here I extend C dash parallel to this point. If I call this as P and this I call this as Q, then C dash Q is parallel to CP. Therefore, if BPC is my triangle, original triangle, then BQC dash is the 3/4 size of the original one. Just imagine, isn't it 3/4 size of the original triangle? Just try to visualize. We know that tangent to a circle exists only when the point is situated outside the circle. What happens to it when it is inside? If I consider a circle like this, then if I have a point somewhere inside the circle, how is the tangent possible? So 0 is the number of tangents for it. To construct the tangents to a circle from a point outside it, we are given a circle with center O and a point P outside it. We have to construct the two tangents from P to the circle. we follow the steps of construction again. Join P to O. What are we having? We have a given circle, that is this one, and a point P outside it. So initially we are having a circle with a point P outside it and with the center of it as O. We have to construct the two tangents of the circle. Join P to O and bisect it. Suppose I have this as O here. I need to join both of them and I need to bisect it. So I bisect it like this. Bisecting means cutting it in the midpoint with a 90 degrees. With M as center and OM as radius, draw a circle. With if I call this as M, this becomes my center, and with OM as radius, I draw another circle. Right. New circle intersects the existing one at R and Q. This is my intersection points R and Q. Then PQ and PR are the two required tangents. This was my point P. Then PR and PQ are the two required tangents. Now I will ask you one question. If PQ and PR are my tangents to the circle, this circle, then prove that when I extend a line from here, the angle which it subtends with this line, OP, is 90 degrees. Can you try it out using similarity of triangles or any other way? Keep practicing. Always relate geometry. Try making use of all the steps of construction in order to draw perfect figures. Use a compass, scale, and a protractor. Do not be messy with your work. Thank you. Hope you understood.